Once you get comfortable with the idea of streaming data through memory, the next optimization we can apply is what's called double buffering, and so we'll look at that next. The idea here is that instead of having one thread that's doing both I/O and computation, we run two threads, one for computation, which is the main thread, and its job is to take the data in an input buffer, call f of x for every one of those objects, and make sure the data gets into an output buffer. Meanwhile, in the background, the second thread is in charge of I/O. Its job is to drain output buffers when they're full and write them to disk, and to fill input buffers when they're empty and read them from disk. And the goal is to have both of these things happening in parallel so that your I/O and your compute are overlapping. You might ask, how do we get parallelism, particularly if we're on a computer with a single core? And the answer is that the disk drive itself is a parallel device. So when the I/O thread goes off to make a request from the disk, we can continue computing in the foreground while waiting for a response from the disk in the background. And so the compute thread can run while the I/O thread is blocked. And this is a general theme in building high-performance I/O intensive systems like databases, which is that your I/O should probably be handled by a dedicated thread so that compute can happen while the I/O thread is idle. At some point during double buffering, our I/O thread was done with its job. It's filled up an input and drained an output. And then the compute thread finishes working on the buffers it's working on, and we can swap between the two threads so that they operate on each other's buffers and hand off. And so now the I/O thread gets to work on the buffers that the compute thread is now finished with, while the compute thread begins to work on the buffers that the I/O thread filled up for it. And so you can see that they swap buffers between them when they're each finished with their current task. Double buffering, I should point out, applies to any streaming algorithm, not just sorting, but really anything we look at during the rest of the course, assuming, of course, that you have extra RAM buffers to spare. So for simplicity in our future discussion and in our analyses, we will not account for double buffering, but you should be aware as a good system implementer that it's a useful optimization to keep in the background because it allows you to essentially read ahead of your compute, and that way you're computing while you're doing your I/O.